My name is Justin Lee, and I managed to spell my name right. I couldn't see it quite right on the screen there. So I work at Red Hat now, and it's newer for me, so it's less impressive than it may sound. But I work on the serverless team there, doing mostly Go and Python and YAML programming these days. So I don't get to use Kotlin professionally as much as I'd like to, but it's still one of my favorite languages. So before we get into all this, how many have heard of Kotlin before today? Yeah. How many of you have used it? A handful. How many are thinking about using it? Well, you're here, so it's at least probably on your radar. Otherwise, anyways. Okay, well, great. Just real quickly, I hate doing slides like this, but I wrote it today after I saw a friend of mine talking. I thought it helps us set some context, right? Like, who am I, and why should you care what I think? In case it matters, I've been doing Java since '96, which I like to highlight simply because there's a lot of people who come talk about different languages and I'm not here to promote Kotlin because I think Java sucks. I love Java. It's one of my goals on the serverless team at Red Hat to make sure that Java and the JVM is a viable option in the serverless world. I'm not sure my manager quite agrees with that, but that's my personal goal. So I love Java. I'm not here to trash on it by any means. But I'm at Red Hat. I worked at Sun for a while in Oracle. I was on the WebSocket expert group. I'm currently on the Servlet 4 expert group, which may or may not ever finish, depending on what Oracle decides to do with Jakarta EE. I am a Java champion, because I love Java. And more importantly, I guess, I've been using Kotlin. I was trying to figure it out last year when I went to KotlinCon. It turns out I've been using Kotlin since about 2011, 2012. I was using beta versions of it, and I tried to find out what was the furthest back I could find a reference of me and Kotlin in the same sentence. And I found a question of March in 2012. I was building a project and I had a question. So I've been using Kotlin for a long time and I've watched it kind of evolve. And if you can't tell, I'm really excited about it. It's one of it's the first JVM language I've used in a while that makes me really excited. All my personal stuff is in Kotlin now, is how much I believe in it and how much I enjoy it. I don't get to use it professionally yet, but I'm trying. So what I'm hoping this talk will do is give you a little bit of a taste of, we're going to look at some basic syntax, just so you can know, how do I read what I'm looking at. It's not complicated, the language, which is one of the perks of it. I like to describe it as somewhere between Java and Scala, right? Scala brought all these great, first-class functions and higher order blah, but then it also came with a whole bag of complexity that it was hard to take small bites. You had to kind of swallow it whole and hope it all digested. Kotlin is, the guys at JetBrains describe it as a journeyman's language. It was designed for programmers to just get their job done. It's not breaking new ground. There's no terribly exotic features. Every feature you find in Kotlin, you'll probably find in a different language. They weren't trying to be creative. They're trying to take all these known productivity aids and I hate the word best practices, but all these things that they're useful in other arenas and bring them into the JVM in some sort of cohesive, usable package. I think that for the most part they have succeeded. Hopefully by the end of this talk, you'll at least have some opinion one way or another on it, and that's my hope. So I don't like doing slides because code on slides is never fun. So the first step, which I meant to do before everyone came in, so I'm going to fix the font.
Hold down your command key and scroll up. That will scale the font.
That's true. Let's try. That made it big. Can everyone in the back read all that? I see a thumb. I think that's a thumb. So, okay. So I have a script. Mac and its concept of full screen is annoying. So let me find out where my script went. So this is what we're going to cover. If you can see that. What? Oh, I have the split. I'll regret closing this later, but it'll be fine. It'll be fine. So this is what we're going to cover for what it matters. That's readable, right? I can bump it up. Somehow, nope. That just changed my screen thing. That was a bad suggestion. Okay, so So we're going to start with some basic stuff. This is kind of an amalgam of two different talks I give. One is basically just an intro, and the other one is like all the interesting features. This is a bit of a both. So we're going to start with some basic kind of introduction stuff, look what the syntax looks like, some of the more lower level features, and we're going to kind of move into some more interesting things. Now, since this is a combination talk, I'm not sure I can get through all of this. So I'm going to skip the stuff about the Java interop, which is very fascinating. If you've ever tried to use a Scala library from Java, anyone ever tried that? Remember how weird it felt? You could tell it was Scala. Kotlin at least has some nice like annotations and features to make that. It doesn't smooth it all away, I don't think, but it definitely makes it almost not noticeable that it's a Kotlin library. We can come back to that if you want. It's interesting, but maybe not as compelling as some of the others. But yeah, and then we'll work through. So the one feature, we're done. No, we're not done with that just yet. The one feature I like most about Kotlin that not everyone necessarily might agree with is nullability. How many people know that Kotlin has nullness in the type system? Okay, so here's what that looks like, all right? So this is your basic class. As you can tell, it looks kind of like a Java class. It's nothing terribly complicated. Instead of public void, it's just fun, short for function. Kotlin defaults to public by default, rather than package private like Java does. They audited millions of lines of code on GitHub and found out that most people are declaring things as public. So they went with the least boilerplate option. And then if you want, there's private and there's internal and I think protected. But anyways, so this is a function. There's actually a unit test, a JUnit, so we can run it to show you what nullability looks like. Now, Kotlin, one of the things I like about Kotlin is it has type inference in a way that Java sort of is getting with Java 10, with its var keyword and various other bits. Kotlin goes all in on type inference. So for the most part, you never have to declare a type unless you're doing something very, very specific, like around collections. Like if you specifically want it to be an array list, you should declare it as an array list. Otherwise, you can let the type inference just say it's a list, because most of the time list is all you need. So in this case, we're declaring a simple variable called s. Like Scala, if you used it, var versus val. Var is mutable, val is final. So sort of like Java 10 has, except Java 10 didn't include val, unfortunately. So in this case, we're declaring a variable called s, and it's going to be a type of string, and you'll notice the question mark there. The question mark tells the compiler this value may or may not be null. We just don't know yet. The difference being if you just declare that, it's a string. Definitely a string, will never ever be null. Now the perk of that is like you never have to check s if it's null in this case. You can just use it and you're guaranteed to never get a null pointer. And there's some escape hatches where that's not entirely true and you'll hit it, everyone does. But for the most part, this is how it works. So this might be nullable, and as you can tell, it calls a function called maybe. Maybe it returns a string, maybe it returns null, we don't know. We have to do some checks. So there's a couple ways that this works. So the first one, this little Elvis operator that I have to say, I'm refactoring a large project now. It's in Java. I'm not quite brave enough to convert it to Kotlin because it's not, people use it, right? So it's not just my code, otherwise I'd convert it to Kotlin and move on. But there are costs to moving a project, changing a project's language. Everyone who's ever contributed would suddenly stop because they don't want to learn Kotlin just to contribute. Anyways, but I wish, this is the one thing that I really miss in Java code. And it's one of kind of the smaller details that works all the time, but this basically says, I want to print an S, unless it's null, and then I want to print, never print a null, right? So that's the first way that we can check a null. So in this case, you can see, you probably can't see in the bottom. I've never gotten this bottom part, the font thing, to change without really screwing up the rest of the UI, so I'm not going to do it. But you can read the code at least. So S is null, and you can see more importantly in the console, that's a decent font. When we print it, we get never print a null, which is what we kind of want, right? So it's a very succinct way to say, use this value unless it's null, otherwise use this default value. You could, one of the things that's interesting about Kotlin is that everything is an expression. If, try, there's a when, which is sort of like a switch, only nicer. Everything's an expression. If, so you can use them as expressions in a line. So you can even do something like this. You're going to print s as it's a null, else you're going to throw a runtime exception of, what are you doing? And that compiles. Now you may say, that's weird because throw runtime exception doesn't have a type, right? It unwinds the stack. There's a type called nothing. Everything, essentially, nothing extends everything. So it's like the bottom type, right? In Java, everything extends object. In Kotlin, everything extends any, technically any question mark. At the bottom is nothing, which is useful for if you have error handling and you're trying to use it in an expression. Normally, if it's like it goes and does maybe null checks or range checking, and if it's outside the range, throw an exception, but you still need that expression to return a value so that you can infer the type. What the nothing lets you do is the compiler knows this function will never return. It returns nothing. It doesn't return void or null or unit in the case of Kotlin. It never returns. So you could use it in expression to say, do this or else do this. This one's going to throw an exception. It'll never return. Ignore this part when it's looking at type inference, which lets you do these kind of nice little one-liners like this. So that's what's happening here, is that this expression type returns the type of nothing. But it can still infer that the result of this expression is a string, actually a string, not question mark, because we're checking for nullness, right? So, but enough of that. The other way you can check it, you can say, you can do the standard Java version of it. If it's not null, then we come in here. Now what's interesting here and what you're not seeing in this code, you'll see it here in a minute. We'll do new s is equal to s. And it's going to, now, IDEA, if you probably haven't used Kotlin inside IDEA, but what you can see here is that in the gray there, that's not actual code. That's just a type hint that the IDE pops up for you, which is useful if you're trying to figure out like what the type of an expression is. So it's a nice way of not including that in your code, but you can still kind of see it. If you find it's too noisy, you can turn it off. I find it's useful, personally, especially when you're trying to figure out why is this not compiling and why is the type inference weird. You can see right there in your IDE. So, but we'll come back to this one. You can do the if check and say, if it's not null, print something. The other option is this guy here. And now this says, if s is not null, then we're going to call this function called let. Now let is something brief diversions, is an extension function, which we'll look at, that is only called if s is not null. And then it takes a lambda as its only parameter. And inside that, you can say, now if we say val new s is equal to, let me see if it'll do this because it's local. Not unit. There. So if you don't declare a parameter to let, the default name is it, right? You can call it whatever you want, but if you don't give the name, you get it. So in this case, as you can see, we declared a new variable, assign it to it, and the inferred type, as you can see, is string with the not null, right? So inside this block, you can use, technically you can use s as well, but you can definitely use new s and know that it's never going to be null because you're never going to get into that block if s is null. And that's two ways you can handle it. So just to illustrate the point more, so here's our function maybe. Right now it returns a null. We're going to switch it to return an actual string. And then when we rerun, suddenly we get some different things. You can't see down here, it says s has a value of how about now? But the interesting thing is you can still do, when you do the print line, now you get how about now printed out because s is not null. The null check, you kind of get the same thing. You made it. And then s didn't execute when when S was null, but now it does. Ah, why did it skip? S question mark, S is not null. Why did it bounce? Oh, because I hit F8, which stepped over the lambda. Sorry, it was supposed to step into the block. There. Threw me for a loop. S is now not null, so it steps into your lambda, right? So this seems like a minor thing, right? And it sort of is once you get used to it. But I converted a rather large project from Java to Kotlin. IDEA has a nice feature that says convert Java code to Kotlin. It'll just go convert it all for you, which is really nice. If you want to like play with it, you can convert your project to Kotlin using the IDE. And when you figure out like, oh, it all broke, you can just git revert and you're done. But it'll convert it for you in bulk, which is nice. But I did that for a project, and I found an unbelievable number of places where I had like null pointer vulnerabilities. And I didn't know because I just used variables and didn't care. Turns out it was sort of fine because this code's been in use for 15 years and it hasn't crashed yet. But it highlighted for those places where I should have been doing proper null checking, but I wasn't. And in Kotlin, you're forced to do that because the type system and the compiler requires it. So this is sort of a big deal in practice. Now, briefly, I didn't start my timer. That's OK. We have 30 minutes. I mentioned extension functions. Now, this is another feature. That's probably a bad idea. So an extension function, how many of you have written a function like, I wish Java had this method on, say, string. Simple example. Let's just write one. So what we want to do is we want to make a function called toTitleCase, right? It takes in a string. If I can type. Strict math, what is wrong with you? Sometimes it's nice. So it takes in a string and it returns a string, right? And then the way you always have to use this is, for example, you do this, toTitleCase. This won't make a whole lot of sense in context because whatever, but this is how you'd call it. And how many of you have written these utility methods like this, where you have to like pass in the thing, and somewhere you have a class, it's a static, whatever. It's just awkward, right? It's not terrible, but it's cumbersome, and it can be cumbersome. With an extension function, you can do some very fun things. So in this case, we're going to say function, and we're going to do that, right? Now we've just defined a new function on string that we can call on any string instance that we want. Or, if you're so inclined, any nullable string instance that you might want. So now whenever you have a string reference, you can call toTitleCase, and it just works. So how does this work? How does this look in practice? You see this turned red because my function disappeared? You can do that. Oh, we don't need this anymore. Because now this obviously is not what you want, but you can return, oh, I cheated. I shouldn't do that. Teaching bad habits. All right, so now this is an extension function on the type string. And inside it, you have a this reference, which refers to whatever the instance that you called it on. So in this case, inside this function, we can get into, let me see. No, you guys can't see it because this is too small. The this refers to, when you get into the function, you'll see that this on the toString says, how about now? So it's a nice succinct way to add functionality to classes that you don't necessarily own, but you want to like add a little bit of functionality to it that you can then kind of shuttle around. It's a little trivial in this particular example, but it makes for some nicer code. Yeah?
Is it available just inside this class, or you can access it outside?
You can access it outside as well. You'd import it like you would like a static import in Java. And that's actually one of the nice things about it is you can actually scope it. So if you only wanted this inside, you can have local, this is a class. So only inside this particular class now can I call toTitleCase. So you can scope it to whatever lexical block that you want, really. Or if you're into local functions, Kotlin supports local functions, which is kind of fun, and local classes and local stuff, whatever. But these are extension functions, and this is really great. We'll actually get into this a little bit more when we start talking about writing DSLs in Kotlin, which is fun. So without belaboring that point too much, that's nullability. Seems trivial. It's awesome. Once you get used to it, it's hard to go back to just straight Java. But you can do it. So, all right, so the next thing I want to show is delegation. How many people have spent their entire careers hearing favor composition over inheritance? Everyone's heard that one? And you're like, but that's not fun. It's a lot of work. And so who does it? Fewer hands. Exactly right. I don't do it because, oh, it's so much work. Because, yeah, no, that's cheating. This is actually nicer. He said Lombok for those who couldn't hear him. It's a lot of work. It's a lot of manual work. It's not great. So Kotlin has delegation and has a number of different forms of delegation that we'll take a look at. We'll start with the simple version first. Let's look at the delegation example. So is that still readable? So this is the class called user. It has a variable or property called name. In Kotlin, there are properties and not fields. In Java, you declare a field, and then you're responsible for writing your getter and your setter. If you want it to be read-only, you only write the getter, and that's all like manual. With Kotlin, you just say var name, and now that's a read-writable property. So you get for free a getter and a setter, but you still reference it, and we'll see in a test, you still reference it as user.name, not user.getName. So whether you're trying to pass user.name to a function or you're trying to reassign it, it's just user.name, and then the compiler takes care of calling either the get or the set, depending on the context. So anyways, so what this particular example is doing is we're doing an observable property. So every time this property changes, we want to fire off an event. In this case, we're printing out something. And then this is actually kind of interesting. One of the problems with nullability is there are certain types that you don't want fields to be, or properties to be nullable, but you don't necessarily have them right up front. Think ORMs, whether it's Hibernate or the project I work on, Morphia. You're loading something out of the database, and you know that that field is going to be there, but it's not handy when you construct your class, you know. So typically, if a field is not, or property is not null, is not nullable, by the time the constructor is done, it has to have a value. Right? Otherwise, the compiler just will fail. There's a couple of options to get around that. In this case, we're using delegates. And this one says we're going to delegate this value by this function called notNull. And it's basically, through some compiler magic and language magic, it says we're delegating this value to this function. It's going to return an int and not a null at some point in time. So compiler, don't freak out, because we're going to initialize it sometime later. And then we have this created value. It has a type of local date time. But you can see here we're delegating by lazy. If you ever have a property that's really expensive to populate, whether you're doing a calculation or you're loading a 40 megabyte XML file from disk or across the network, whatever it is, it's a lot of work to load. And you don't want to create it every time you instantiate an instance of your class, right? So you can say this is a lazy property. Don't do anything for this particular property until someone references it, and then this lambda will get executed, right? So we'll see that in action. So if we look at the test here, we're going to create a user named Pam Beasley. Office fans, anyone? Yeah. So we're going to create a user named Pam Beasley, but as we all know, at one point she gets married, and now she is Mrs. Jim Halpert. So we're going to change her name to Pam Halpert, and we're going to see what that looks like. So bring up that console. Good. Not you. We're done with you. I wanted you. And the console. OK. So now we have a user. My debug point got deleted. So we have a user. Her name is Pam Beasley, which you guys can't see because I can't change that font size. But trust me, her name is Pam Beasley. But now she got married, so we're going to assign it using the property syntax to Pam Halpert. And I hit the wrong button again. One day I'll learn to use my IDE. No, it's just hanging there. There we go. So we just step through it. I'm going to close you. And you can see now here, you can see Kotlin string is changed from Pam Beasley to Pam Halpert because it executed the delegate here that we had defined, right? There are a bunch of different delegates you could use. This one's observable. You can do some interesting things with it, but that's just one example. So now how about this age thing, or the lazy creation, all right? I wish you guys could see this. Does this work? Nope. The spread finger thing doesn't work either. Inside user, at least for you guys up front, I hit the wrong button. It starts off as null, and we're going to call local date time. Did I read? We're going to get it fixed. Oh, that's why. I don't know why that takes so long today. It shouldn't. Console debugger. There's my variable. All right, it says data's collecting. It says collecting data. Oh, I think the debugger is invoking the property. That's why it's showing up as not null. Anyways, it used to be null until the debugger tried to render it, and then it called the function. Sorry. And now it has a value. And you can see the user created in the console comes up. Now it has a time. So that was the delegate not null. So with the age was lazy, as you'll recall. Remember, we hadn't initialized it with anything? Or it was the delegate not null. If we try to print it now, we get an exception. And that exception says property age should be initialized before get, right? So this is what that delegate will do if you haven't assigned it. But fortunately, we can assign it a value. We can say Pam is now 29 years old. Happy birthday. And if we print it again, now we get user age equal 29. So it's a nice little compiler workaround if you're trying to load things off a disk, deserializing out of JSON, whatever it might happen to be, that you can say, I know it's not going to be null, I just don't have that value yet. Please compile this as not null. And then you can use it everywhere else as if it's always going to have a value, because by that point it should, as long as your deserialization process is properly run. So that is one form of delegates. And that's kind of interesting. The more interesting version for me is inheritance by delegation is what JetBrains calls it. So who here has ever implemented Java util list, or really anything in Java util, like map? It's like a massive API, right? And you have to implement all these methods and delegate through. It's a lot of work, right? So Kotlin has this thing called delegation by, or inheritance by delegation. So I created a listogram, and this is a simple example. It's a list that keeps, that builds a histogram of its size over time, right? Not terribly useful, but it is demonstrative at least. So it is a normal list, is what I want it to be, but I don't want to implement every single method in the Java util list API. So what I do is I take, this is a constructor, as you see right here, this highlighted bit. Does it help when I highlight, or does it make it harder to read? Seems like it helps. I hope it helps. So this is a constructor parameter to my listogram of a type called mutable list, which is technically array list. Kotlin makes a distinction between list and mutable list, map and mutable map, and set and mutable set. And it's exactly what it sounds like. One of them you can change, one of them you can't. So in this case, we're going to take a list that's a mutable list because we want to add things to it eventually, right? And just as an aside, Kotlin supports default parameters on functions in general. In this case, it's a constructor. So I can create a listogram with an existing list and pass in that instance. Or if I don't pass anything in at all, it will call mutable list of, which is a convenience method that returns an empty list. Or it returns a list of whatever parameters you pass, but we're not passing anything. So in this case, it's empty. So it defaults to an empty list, this listogram. Now here, this colon mutable list, we're saying that my listogram extends mutable list. If I did not do this, now suddenly you can see the little red squiggly show up. That's saying there are methods on mutable list that you haven't implemented here, and that's the standard thing that we've all seen before. You extend a class and you haven't implemented those methods yet, compiler complains, right? So The magic comes in here when we do this delegation there at the end. We're going to say we're going to delegate by list. So any method, what this is saying is any function on the mutable list interface that we have not implemented on listogram, we're going to delegate it by calling that same function on the list reference that we just passed in as a property to our list. Does that make sense? Did everyone follow that? It's awesome. Because now, as you can see, I only really care about two functions on the interface, add and remove, right? I should probably care about more, but for this, these are the two things. So every time we add something to the list, we're going to take a timestamp with a count. Every time we remove, we're going to do the exact same thing. And then I can get down to the meat of it, and I can draw my little histogram, right? It's just a bunch of stars showing the size of the list. It's not fancy, but it works. So let's see this in action, shall we? So if we go to listogram test. This is what our test looks like. There's a little bit here, but it's not terribly important. All we're seeing here is we're adding a bunch of things to the list, removing some things from the list, adding some more. We're going to sleep for a little while because we want the clock to advance, and then we're going to add and remove a whole bunch all at once. And then we're going to print the listogram, right? So this is what it looks like when we run it. Oh yeah. It's going to take. I've tried that and it always freaks out for me. I keep going back to it though, because someday I'm going to get it figured out and it'll work properly. But as you can see, my list grew. We removed some, and there's the listogram. Now, this is all great to see the Kotlin version of it. That's what we're all here for, right? But just for comparison, what I like to show, because there's two things I like to show here, is I have a Java version of this as well. And this is the Java version. Because there's all those methods, right? And all they do is they turn around and call that. It was not hard to write, but it was definitely not fun to write. It's just tedious, right? Yeah, I knew someone was going to say it. IntelliJ will do it for you. And you're absolutely right. I might have actually done that one. You could use, yeah. But see, these are all like more complicated. This is way better, I think. But yes, you could use proxies. There are tips and tricks you can get around that. But this is the Java version of this. And it's hard to tell, looking through all this code, where the actual business logic of it is, right? Because everything else is lost in the delegation code. So delegation in Kotlin. If there is an adapter, yeah. For like all the swing stuff, there's an adapter. I chose list because there wasn't one. Because I just knew someone was going to say, why didn't you use the adapter? It's like, shut up. Anyways, I'm trying to make a point. So there's two things I wanted to show. When I first wrote this, actually, I always had to apologize because I started using Kotlin. At the shop I was working, we were stuck on Java 6 for a number of reasons. So I used Kotlin, and I learned to use the stream and the mapping and everything in Kotlin, and it was lovely. And I went to go write the Java version, and I got to this point, like, I don't know how to do this with Java 8 streams, and it was ugly. And I always felt bad about it because it was an unfair comparison. So this is actually not so bad anymore. But if we look at the histogram version, we're going to collect everything in the history. We're going to group it by, I had to add a class of Java pair because Java doesn't have a pair class still. I don't know. Everyone tells me because it's hard to make generic and write, and I can't figure out why. But I might just be too dumb for them. So anyways, we're going to group it into a pair. So we're going to break it up into time and size. And then we're going to, we get the entry set. We're going to call stream. Then we're going to map it, and we're going to get what we want, because we do, it's possible that the list changed multiple times in space of a given second. So we want the very last size in that list, right? Because we keep adding for every second boundary, we add size. So 1 second span might have 3 sizes. So we want to get the last one to make sure we get the maximum size for that second. And then we're going to create a new pair. We're going to map it to a pair of, we're going to format the date so that it doesn't suck. And then we're going to draw a plot. And all the plot does is it, as you can come down here and see, it creates a string with a bunch of stars. For every whatever the count is, it creates that many stars. And that builds our histogram, and we're going to map it to that pair. And then at the very end, we're going to come through and we're going to print out the time and whatever the plot was. That's the Java version of it. It could be better, almost certainly, but not as bad as it used to be for sure. The Kotlin version looks pretty similar, except Kotlin has a function called groupby, that was actually the thing that tripped me up on the Java 8 one, is grouping as a collector at the end, and it took me forever to find that. It just wasn't intuitive for me. Kotlin has a groupby as part of its thing automatically. So it's clear, I'm going to group it by the second of the day. I'm not hiding behind a pair class, which loses all semantic meaning. What's the second value in the pair? I don't know. I have to scroll back up. So I'm going to group it by the second. I'm going to map. I'm going to get whatever the value of that list is for that second. I'm going to pull the last one. And then I'm going to map it again. I'm going to format the date to this particular format. And then this is, it's an inline function, if you can believe that. So Kotlin has an inline keyword. So whenever you use that function, instead of saying to parentheses and then value, or argument, in this case, the arguments can be spread on either side of the function, and you can use it as an operator, essentially. So this is a shortcut. It actually creates a pair of whatever this type is to whatever this type is. And in this case, I got fancy with my Kotlin lambdas, and I just say for everything from 0 up to whatever the value is, add a star to the end of the string, fold left, create my string, and then for each print it. And then we saw the Kotlin version. The Java version, whenever it runs, looks exactly the same as the Kotlin version. Although I got more variance in the Java version, and I can't quite figure out why. But just to see it run, to know that it's ugly, but it does run and work. I should have gone for smaller times. I don't know. Now it takes like 15 seconds to run now, 10 seconds. But as you can see, the Java version also produces a listogram. A little bit more work, but it's there. So that's delegation. All right, it is 3:30. Is it really? 3:30. All right. That's delegation. I'm going to skip DSLs because that's not quite as interesting. It is interesting, but it's kind of a niche thing. But I wanted to get to this other example. 2 examples. One will be more immediately useful, and the other one might maybe stir your imagination. So Kotlin has coroutines built in. Anyone use Rx, Java, Rx, whatever, all the different async? It's nice, right? But there's a bit of ceremony when you have your observable of this or single of that. It works. It's better than the alternative. I think Kotlin's version is better. It supports what's called a coroutine. So a coroutine is there's a new keyword they added in 1.2. It's still experimental, but you can mark a function as suspend, which lets the compiler know that it can be used inside of a coroutine, and it's suspendable. So in this case, just very, very briefly, we're running. We're going to execute this function in a lambda called a run blocking, which means we're going to run a coroutine, but we're going to wait for the return value, because ultimately you want the value to come back out. But what this lets us do is we're going to fire up 100,000 coroutines. They're all going to do some work and return. So in this case, we're going to create a list. This launch says spawn a coroutine, and whatever's inside this lambda, go execute it. By default, it uses the fork join pool, but that's customizable. So we're going to fire off 100,000 of these coroutines. They're going to sleep for a second, and then they're going to increment an atomic integer. So that way, when we run it, by the end, we can tell that num value should be 100,000, right? To know that I'm not cheating. So if we run this, building. It runs amazingly fast. I'm running out of time, so I'm not going to run it, but I want it for comparison. I wrote a Java version of it using threads. I tried to recreate, I figured what thread pool they were using, and I'm going to submit a runnable, and we're going to see how long it takes using standard Java threads to do a similar sort of workload. So this, you can't read it, but it says those 100,000 coroutines, which as you can see, counted up to 100,000, completed in 2 seconds and 140 milliseconds to do 100,000 threads, essentially. If I run them as actual threads, that number jumps up to over 2 minutes to run. Just for grins, I ran 1 million of these coroutines the other day, and it took 10 seconds to run 1 million coroutines. And I crashed my JVM trying to do 1 million threads. So they're really lightweight, really fast, and they're built into the language. So if you do a lot of RX stuff, this might be a nice option for you. I've only started to explore this particular feature, but I'm terribly excited about it in some of the stuff that I do. Now, in the last few remaining moments, right, so they say never to upgrade before a presentation, which I did not. But what I did do is I pulled in a completely new demo. 2 days ago, I said, I'm not going to do this one anymore. I'm going to pull in this other guy, which might come back to bite me. Everything worked yesterday when I ran it, but we're going to try it. What's important is the code at this point and not the execution, right? So Kotlin targets not only the JVM, but you can actually write Kotlin and have it transpiled onto JavaScript. So if anyone's writing a React application, normally you write your front end and whatever, then your back end in Node, and we're Java guys. Nobody likes to write Node code, right? I don't. You can actually write your back end in Kotlin and your front end in Kotlin and still build it in React. There are libraries, React Kotlin JS or something like that, to build React applications, but all your code's actually in Kotlin, and at the compile time, it gets compiled onto JavaScript. So you never actually have to write any JavaScript, which is lovely. So it'll target JavaScript. Hopefully, if you've heard of Kotlin, you know that Android developers love Kotlin. It's now an official language on Google. So that one should be no surprise. But what you might find interesting is you can actually write iOS apps in Kotlin because Kotlin supports compiling down to LLVM. So you can write native code to run on your desktop or on your iOS device or your Raspberry Pi, wherever it is you might want to run it, you can compile on the native code. So this particular project, and we'll just go through the code because I want to blast through this and have time for some questions. We'll look at how that's set up. So you can write a multi-platform project in Kotlin where everything is separated off into modules. Right now you have to use Gradle because it's experimental and they've only done it with the Gradle system and they haven't fixed Maven yet. But you have certain types of modules, and you may or may not be able to see those side bars. It's the worst part of presenting, I think. But now presentation mode gets rid of the menu things. So what you can't probably read back here is there's an Android module, there's a backend module, there's a common JS, common JVM, iOS, and web. These are different modules. Now this application is actually the conference application for KotlinConf from last fall. And this was used, I actually used it as a user and as an attendee. Their entire conference was run by Kotlin code live, whether it's Android or iOS or whatever. All of it was, this code actually works even though it doesn't on my laptop for a number of reasons. But we'll look and see why. So you have a common module, and what it lets you do is you can come down into here. There's a date class. You can see the keyword up there on date called expect. It's sort of like defining an interface, or if anyone else is old enough to remember Corba with IDL, yeah, I heard some chuckles, some groans. It felt a little bit like this. So what this says is in this common module, we're defining a common API, and somewhere on the target platform, you can expect a class called date. But we're not going to tell you what it is. Just look for it. You'll know it when you see it, right? That's what that says. And then we define, or I say we, JetBrains defined There's an operator. You can define your own operators, sort of, in Kotlin. But there's a couple of extension functions on date to make it a little bit easier. But this is in the common module. So it's sort of like defining an interface, but it's like cross-platform in every sense of the word. So if you go down and look at, I don't know why I opened that one. Date format's a weird one. If you go down to look at common JVM, it's in a file called JVM date. There it is. Here you can see there's a class called date, but instead it uses actual. Now this tells the compiler, the build system I should say, that this is an actual implementation for that date that you were told to expect for the JVM platform. And the interesting thing about it is you can see actual, because we had told it over here, here's all these functions that you should see on the class. Actual, you can think of actual like override in that sense. It serves the same purpose. But if we were to rename this, now you can see it's not only white now, but it also has a red squiggly. Because we were told to expect an actual function called date or get date, and it's not here. And now you're telling me this is the actual get date too, but I wasn't told to expect it. So the IDE can help guide you that this is what's there. So I would run it for you, but I got the Android app working. So just for comparison, if you go into this is the JavaScript module, this is the JavaScript date, actual external date, and I'm not a Node guy, so there's a lot of guesswork in this part for me. This is telling it to use the JavaScript date that's built in. So there's no actual implementation here. But all this is one big code base that they use to run everything. And the nice thing about it is in the common directory, they have all their business logic classes. These are data classes. If you've used Scala, it's very similar to I always forget the Scala term for it now. Type classes? Case classes, that's the word. Similar to Scala case classes. This basically says it's a data class. You get a toString, an equals, and a hash code for free. And if that's all you care about, then why write that stuff, right? Just slap data on it, the compiler will build it for you, you're done. And then as you add properties or remove them, those get updated for you. You don't have to manage all that. Anyways. But the nice thing is you can build all your common data models, your business logic, as much as you can in these common modules. And then on the target platforms, whether it's the Android or the iOS, you can just worry about your view models and things like that. So this is something I'm going to, once I get past some of this conference stuff, I want to start building an app on top of this, because this is really interesting, because I want to write apps. Who doesn't, right? But I don't want to learn Objective-C. Maybe I'll learn Swift, but with this, you don't have to. You can write it all in one language, right? That's the promise of Node, right? You can write JavaScript on the front end and the back end, except I hate JavaScript, so I'm going to use Kotlin. So anyways, it's now 3:43. I don't see anyone wagging a finger at me. 2 minutes. All right. I know that was a whirlwind, and I'm sorry a little bit about it, but there's so much to say. Are there any questions I can answer? Yes?
I work on a platform that's written in Groovy, Groovy.
Uh-huh.
Very similar to this, but it's kind of dying. The ecosystem's going away. What's the chance of that happening here? This is JetBrains, baby, right?
This is from JetBrains. So the question was about viability of the ecosystem because Groovy is slowly dying. I mean, even Gradle is moving.
I disagree.
You're wrong. I mean, even Gradle has like a Kotlin dialect now for their build file, and Gradle is why most people use Groovy, right? I'm not a wizard, so I can't predict the future, but to me it seems pretty promising that it's going to be around. It's an officially supported language on the Android platform, so there's all sorts of stuff going on there, both inside and out Google. If you're into data science, there's a lot of work in the data science realm about building up some Kotlin libraries based on this. When I first started using Kotlin, it was a pretty small community because it was still a beta language, and what kind of idiot writes code on a beta language? Like I knew a lot of the people, like someone would say, I just released a library. It's like, I know that guy, I know that woman. But now I'm happy to say, I went to Kotlin Conf last year. I didn't know anybody. You know, there's all these speakers I'd never heard of before, which was awesome, you know, because it's just the interest is wide and varied and some very surprising places. So I think viability, this is a good bet. JetBrains is building more and more of their stuff on top of it. So unless they have a change of heart and decide, maybe Groovy was good enough after all, I think it's going to be around for a long, long time, I hope. There was a couple of other questions. I saw hands. 1 second.
What's the state of the ecosystem of debugging? So if I attach to a JVM that's running mixed Java with Kotlin and Scala, Groovy, can I step through with Kotlin, or
It's
no compile the JavaScript that I attach to the browser and see my source map?
okay. So there's 2 questions. One about debugging on the JVM, and one about debugging in Chrome, essentially. So to the first question, it's seamless debugging on the JVM. It compiles onto bytecode. It's really nice. I once used a project that was written in Clojure, and there was a bug. It was in my code, of course, because libraries are bulletproof. But I have like Java stack trace, and then I'd hit like the Clojure bits, and then there was like a glitch in the matrix. You know, just everyone like, and then more stack trace. You know, I'm like, what happened in that part? You know, I didn't know. You don't have that with Kotlin. It's all very clean. I mean, it's written by a tools company, right? So when you're looking at stack traces, it looks like a Java stack trace. You know, it points to a line of code. It's very readable. So in my experience, it's been very seamless. Now, I've had Java and Kotlin projects. I haven't had Scala and Groovy all in the mix, so that your mileage may vary. But I can't imagine any oddness from that would come from Scala or Groovy. On the browser side, you can debug it. The compiler generates source maps. So your JavaScript line code has links back into where it came from out of the Kotlin code. So as you're debugging, you can see in your browser, like, this is a bug. And then you can actually attach to a Chrome debugger out of IDEA, which is sort of awesome. And it can link back to your Kotlin code. So you can kind of round trip it rather nicely.
How about the data, Spring Data, and Data GPA unit test, and all those features which are there on the Spring platform on Java? At one time, we considered using Kotlin for tests, again experimentation, but we extensively use Data GPA test on our site. I was wondering whether all those will be compatible with Kotlin.
I've yet to run into a Java API that I cannot use from Kotlin. I know the Pivotal team is doing a big push on Spring Boot in Kotlin. I have a couple of friends who literally go all around the world talking about bootiful Kotlin. So if you like Spring and you want to play with Kotlin, seamless.
There's also Spring Boot, which is the next version of Spring Boot, which will be Kotlin.
Oh, nice. All right, one last question.
So what is the underlying implementation for coroutines? Is it Quasar or is it something JetBrains created?
It builds on top of the fork join pool.
So it's actually using Java threads.
Yeah. As far as I know, I started digging into it yesterday, and the weeds get pretty thick. But it's definitely fork join pool stuff in there. They may pull stuff in from the side, but I've never seen any Quasar library come into the mix. So, okay. Real quickly, in case anyone wants them, there are. Come back to me. There are some resources. Kotlinlang.org. There's a Slack channel. There's an IRC channel if you're into that on Freenode. There's try.kotlin.lang where you can actually type. It's like a mini editor. You can type in Kotlin code in the browser and run it and see what happens. And then if you're New York based, there's a meetup. We meet like every 6 weeks, and we'd love to see you. So, thank you.